Okay, hello everyone. Um, this is going to be the assignment with the series parallel circuit. So simply we have a 9 volt, and then it's supposed to go through two different parts of the series. So this is the one part. The first part is composed of a single resistor R1, and has resistance 5 kilo ohms. And then the second part of the series, that's where it switches into a parallel um, and a parallel circuit, and then it has simply two different branches. This is the first one, R3, composed of 6 kilo ohms, and then the second branch of the parallel series is composed of these two. Um, That one is R2, 8 kilo ohms, and this one is R4, 4 kilo ohms. So here, R4, as you can see, 4 kilo ohms. We got, not sure what happened there, but anyway, R2, 8 kilo ohms, R3, 6 kilo ohms, R1, 5 kilo ohms. Okay, and then we got our 9 volt. So simply, it's going to go through here, and then it's supposed to go through the 5 first. But then instead of a negative cord going here, I put in a meter so we can read the current. All right. So basically, this should be IR1, and then after that, it's I got this right here to read the voltage, from here to there, which is VR1. And then they're supposed to meet, so it's going to travel that feed that goes through this thermometer, through this resistor, is supposed to travel through that one as well, and these two. So what happened here is I got my R total, which is on paper first, R1 plus uh, the combination of these three. So 1 over R3 plus, since these two are simply can be combined into two big resistors, so we can do 1 over R2 plus 1 over R4, and then 1 over the total of these two, plus 1 over that, and then 1 divided all these three. So we got the 5 kilo ohms plus uh, the 1 divided by the 1/6, and then 1/12, which ends up to being 4 kilo ohms, and then 5 kilo ohms plus 4 equals 9. So we got 9 kilo ohms as the total of my R total. And then I total is simply dividing my total voltage by my total resistance. So 9 over 9 is 1 milliamps. And then as far as my R1, I did the 5 volts by 5 kiloamps. I got the 1 milliamps. And then as far as my where's my R2? IR2. Um, no, not this one. R2. This is R2. Okay. So let me run it because there are so many chords here. So boom. This is both my I total and um, IR1. They both have the value of 1 milliamp. but the difference is one of them, the I total is 9 volts over 9 kiloamps, and then my IR1 is 5 volts over 5 kiloamps, but they both have the value of 1 milliamp. Okay, then right here is the voltage of my going through my first resistor, which is R1 that has 5 kilo ohms. So 9 times 5 over 9, which is 5. So that's that. And then the rest of the 9 volts is going to be the 4 volts, which is going to be split between those guys. So I got my R3, which is R3 is 6 kilo ohms. So voltage stays the same in parallel. So 4 over 6 is 0.67 milliamps. And then the other two is going to be, these two are going to be the same since simply they're on the same branch. So IR2 plus IR4, or IR2 equals IR4, which is 4 volts over 12 kilo ohms, which is 0.33 milliamps. So I got this is the 333 microamps or 0.33 milliamps. And then I got, let's see, this is the voltage of of these two. So the 4 volts is going to be split between this one and then these two combined. So since this resistor is double these two, because this is going to be 1 over 6 versus 1 over 12. So the 4 volts is going to be split 3 ways. 2 of those are going for this one, and then the third left is going through these two combined. So I got here the 1.33 volts, and then here I should have the that's going to be my 2.66 or 2.67. All right. Okay, the voltage is going to be the same. And here again. Okay. All right. So there we go. So my R total is going to be the 9 kilo ohms. My I total is going to be 1 milliamps or 1,000 microamps, which is also my IR1. My IR2 is going to be the 0.33 milliamps. The IR3 is going to be the 0.667 milliamps. And then my VR1 is going to be the 5 volt, and then my VR2 is going to be the 4 volt.